Alright, hey guys, I wanted to show you how to do a few things here, simple question, on chapter 20. Alright, so most of this works pretty much the same as it worked for proportions. For proportions, we looked in our calculator and found the one proportion z interval. But when we talk about means, we do something very similar, but just slightly different. So if I get my formulas up here, here's your general idea for z-score, data minus mean over standard deviation. Right? When we did this thing for sample proportions, we did the data was a sample proportion, the mean of the sample proportion, and the standard deviation of the sample proportions, which ended up being this thing. And the nice thing about it was when you knew a population proportion, which was the mean, you could also find the standard deviation of the proportions because it's based on the same p. Right? So if you know the mean, you use that mean to find the standard deviation. So theoretically, everything's the same for the means, right? We want to do the sample mean minus the mean of the sample means divided by the standard deviation of the sample means. Problem is, for sample means, this population standard deviation is not going to be known if I'm trying to estimate the population mean. So here, again, I used the mean to find the standard deviation. I assumed the mean was something. I easily found the standard deviation. Here, assuming this mean is something isn't going to let us know what the population standard deviation is. So I have to appeal to using the sample standard deviation, which is S instead of sigma. So instead of using the standard deviation of the sample means, I have to use the standard error of the sample means. And when hold on. Okay, I'm back. So I guess the only other thing about this t-distribution is it does depend on the sample size and the degrees of freedom. So maybe I will just kind of degrees of freedom, which is just is n minus 1, right? So whatever your sample size 1, you subtract 1, that's your degrees of freedom. Okay. So when I go to the problem, everything is essentially going to work the same. If you look under here, under stat and under tests, I have z tests and z intervals. I guess I'm doing an interval on this problem right here. And z intervals and t intervals. The z interval is only for the times when I'm here. I'm estimating the mean, and I know the population standard deviation, which happens essentially never. Okay, so for hours, we're pretty much never pressing this z interval button on this z test. I'm talking about means, it's t interval, and it's t test. I'll look at my problem here. My summary statistics, they come in my t interval. Hold on. Okay, back again. Okay, so I'm going to go into my t-interval, and I put everything in, right? So they say my x bar is my mean. That looks like 98.298. Standard deviation is 0.6675. And they asked for sample size, which is 52. And the confidence interval was a 99% confidence. So there you go, spitting out my answer. 98.05 to 98.55. Oops. Okay, it took me way too long to realize I had left a little comma stuck in there. So okay, it was right. No, good news. Math still works. But yeah, so I just go to that t-interval. Now you notice when I went to that t-interval, I guess I might as well finish it off. Right now, again, right, so what we're saying is 99% of my intervals that I make will contain what the actual true mean is. I don't know what the mean is. So I'm 99% confident, based on my data, that the body temperature of an adult falls in this interval. I'm sorry, unadult is what we realize this is wrong, right? I want to have the body temperature for all adults. The mean body temperature for all adults. That the interval contains the mean body temperature. Okay, this is the one. And 99% of all adults, nope. 95% of all random samples will produce intervals. Yes, this is exactly the one. That's always what we're saying, right? We're talking about 99% of the intervals. 99% of adults, I'm going to say right there, we're going to throw that out. We're going to throw that out. 99% of all will have a mean that is in this interval. No, there is a fixed mean. We don't know what it is, but I'm 99% sure that it's somewhere in here. All right. Anyway. Okay, and I wanted to do this other one too. I believe it's number 11. Oh my gosh. All right, geez, keep getting distracted. Okay, well, so for this one, right, they gave us a set of data, right? So we want to know, when I went to my t interval last time, which was down here, I just looked for t interval, there we go, right? I had two things here, right? I had data and I had stats. Stats are if I have the x-bar, I have the standard deviation, everything. Another one for if I have the data, and they just call for the list for you to use. So I took the time, I took this data and I put it in a list. There it is. You go under stat and you go into edit, and I stuck it there under list 1. So there's the data. I just stuck it in there. Okay, if I quit out of there then, and I just go to, what is it? It's 8, isn't it, right? So I go to data, I just use list 1, and they say 99% confident. And there it is, going to spit everything up for you. So it calculated your mean, it calculated your standard deviation and everything for there. Let me just go ahead and figure this out, that we know they satisfy the condition. We don't know they were selected at random, but it's reasonable to think that they were. So I guess they never said it specifically, but they didn't say they weren't. So I guess, oops. Okay, fine. No, the bags were not selected at random. But it's reasonable to think they're representative of all bags. Oh, no, they weren't selected at random. They specifically picked them for that. Okay, oh, whatever. That's not really what I'm getting at here. Is it 10%? Yes, 6 is definitely less than 10% of all bags of chips. Yeah, it's nearly normal. I guess I can tell by looking. Oh, no, that's nothing. So we're going to go ahead and say that. Okay, so the Y bar and the S, they gave us right here, right? So I guess I could add them all up and divide by the total, but I got it right here in my thing. So I'll just do that, and my S is 0.43. Okay. My 95% confidence interval, there he goes, 28.12. Oh, 1 decimal, please. And 29.5. Oh, 95% confidence. Sorry. So stat, tests. I had left it on the 99 from before. So there it is, 28.1. shoot, did I just get the same thing? %, confidence interval for these things. 1 decimal place. Okay, no, okay. 28.4 to 29.3. Aha, okay. Okay, and when it's hypothesis tests, they work the same way. So instead of picking t interval, pick t test, but then do it just like you did everything else. So yeah, I mean, so that these really shouldn't be all that different, and all of these things are really the same stuff we were dealing with in the last one, right? 95% confident, 95% of all bags of chips, nope. 95% of the chips, nope. Contains a true mean 95% of the time. No, there is a true mean. It's the same thing. It's the same thing always, right? So, okay, then we're done. Oh, comment on the company's stated net weight of 28.1. So I'm assuming that I'm 95% confident it's between 28.4 and 29.3. So 28.1 is outside that interval. So since the interval is above, I can say that they're filling them more than the stated weight. Yes. Right, because it's all above 28.1. All right. So that's about it. Again, here is a test. Again, it works the same thing. Put this data in there. Just put t test instead of t interval. I guess that's about it. If you guys think of anything else, send me an email. I'll be happy to help you out. I've moved this homework assignment back for everybody to tomorrow. Moved everything back a day. So anyway, if you have any other questions, send me an email. I'll try to work on it this week.